All right, NES makers, ladies and gentlemen, it is day 16, and I'm feeling much better after a good night's sleep. I'm actually up early in the morning, and I'm going to crank this out first thing. If you're following along, today is the day after Mario Day. It is March 11th. So big party at the studio last night. Made me a little bit exhausted last night, but I still got the tutorial done, got my 20 minutes in, and we're going to do that again today. We are going to make a push block today. And not only that, but I think this is going to take a 2-day thing, but we're going to make a push block that you can push into the space, and then when it is secured in the space, you can push it to a place where it can trigger something. So there's a lot of little bits and pieces, and we're actually going to have to fix a few scripts. We're going to have to write some assembly code, but we're also going to have to fix some existing scripts in order to make this work. But nothing should be too tricky. There are a couple things where there's some explanations of things that if you're not familiar with how 8-bit math works and things like that might be a little bit confusing, but I don't think it'll be hard. So first things first, we need a push block. The background push block, incredibly easy. I already made one on day one that we started, and I'm going to put this push block here. But I'm going to change the color, and I'm going to show you why. I'm going to copy this, and I'm going to put that here. And this is the palette that I'm using. Yeah. And this is what I want it to look like. And the reason this is what I want it to look like is because this is what my ground uses. So when I replace this block with nothing, I'm going to want to see this color. It's going to show the first tile in the tile set, which is fully brown. If I made it this color, it would end up showing this color on the ground. If I made it this palette, it would show this color. If I made it this palette, it would show the right color. But the thing is this color would blink, right? So we'd have this thing that was going, it's going yellow. And if I could make a block just out of black and brown and white, that'd be one thing. But obviously white would be weird for this block. And not to mention, I don't want to change white because that's what my HUD is made out of. All these things are the kinds of things that you think about when you're designing your screens and your palettes and things like that. It's kind of a pain in the butt, but that's working with the NES. So now what I'm going to do is I'm going to flip these colors though. So I'm going to make the top yellow and this side, and this side brown. And that way I've got the lighter color still on top, kind of looks gold. I got the shadow color still on the bottom. Still generally doing the same thing. I'm going to save this. What is going to be weird is that when I push this block, it's going to change it into a sprite version of this block. When it changes to a sprite version of this block, I'm only going to be able to use the sprite palettes, right? So they're not going to be these same palettes, and it's going to look really weird. It's going to change color. I might make it like flicker colors. That way it looks like I'm magically moving the block, and then it'll cover up the fact that I didn't have the same colors. Again, we could put the same colors, but then we'd sacrifice colors on the screen, and we don't want to do that. So I'm going to save this. I'm going to copy this. Control-C. We missed that. I'm going to open up my game object tiles. Open that. Control-V anywhere on here. And the problem is, if I switch over to background palette, player palette, what I have loaded right now is FX and red monsters and blue monsters. This is what my screen is made up of, and none of these work. So probably what I'm going to do is I'm going to have a flicker back and forth between these two, or flicker back and forth between these two, or something like that. And that way it looks like it's magically moving. Either way, I'm going to just hit save. Go to my game objects. Where it says health pickup, that's not going to be a health pickup anymore. It's going to be this block. So I'm going to make a 2x2 block. I am going to give it 2 frames of animation. Frame 1, don't forget, is red monsters and blue monsters. I'm going to make this red monsters. Frame 2 is going to be blue monsters. And so when it's moving, it'll look like this. Frame 1, frame 2. Okay, it's not going to show me the change in subpalettes. That's okay. We'll see it in game. I guess you'll just have to trust me. I'm going to rename this as push block. I'm going to go into object details. I don't want it to be any type. I don't want it to have any speed. I could make it stop if it hits a solid object. That'd probably be a good idea. even though I don't think that's ever going to be a situation, but just in case. And then I'm going to leave this completely alone, other than I'm going to turn the animation on really fast, and I'm going to give it a bounding box. Whole thing is a bounding box. Okay. So I'm going to save that so it updates how it looks. Don't forget to, something that's annoying is that this is actually going to be transparent. So what I might want to do, if I don't want that to be see-through, is go back in and make, on the sprite, make this a solid color, make it the darkest color. I'm going to ignore that for now. Something I can go back and do. What I really got to focus on doing is, in my screen, I'm going to, in my sandbox here, I'm going to get rid of my what's it called? My conveyors. And there we go. All right, so what I'm going to do is I'm going to put my push block in here like this. And yeah, I wish it was a different color, but if I made a different color, we'd have problems with it. Maybe to make it stand out, I would make the top and the right gold. Maybe that would make it stand out as something significant. In fact, I'll do that. Yeah, because I don't like that it's not standing out as much as I want it to. So what I can do is look at my, I'll just do this. Make this gold. And I'll make this gold. And now it's significant because it's a gold block. And if I give it a second to catch up, come back. There we go. Now it's a gold block. Yay. And I can make that gray instead of brown if that's we got those colors to work with. Anyway, I want this to basically behave as a solid object first. That's number one. Let's make it behave as a solid object. So I am going to have to go to my script settings. And I'm going to scroll down to my tiles. And this is, I'm going to make it tile type 11, but I don't want to edit this because then I'd be editing the blank tile. I don't want to do that. I'm going to edit any of my other tiles that exist in the maze base. And why is because then when I go to new, and I was already playing around with this a little bit. When I go to new and I call this push block, if I save this, change to ASM, look at where it's putting it. It's putting it in my maze-based tiles, which is where I'd expect to find this. So I'm going to call this push block, hit save. And the other thing I'm going to do is over here, I'm going to set up my tile type 11 to be maze-base tiles push block. And then I'm going to go to project labels and tile 11. I'm going to call it push block. So when I look at it on my screen, I will have to refresh the screen. So just click off, come back. And now you can see I've got push block. So I'm going to take push block and I'm going to make this push block. And all I'm going to do to start is I'm going to make push block the same as solid. Just do the exact same thing that solid is going to do. So I'm going to come here, script settings, look for the tile for solid, edit, and I'm just going to copy solid. I think this RTS is redundant right here, but it's okay. It's not going to hurt anything. Just put that in my push block. And now if I save that, it should work exactly like how solid works. There should be no difference. The only time there will be a difference is if you're working on like a platformer, because if you're working on a platformer, we also want to check to see like if ground is under my feet, and we'd have to make an allocation to make tile type 11 act like ground and things like that. But other than that, especially in this type of game, I should be able to walk against it and it's solid like that. All right, so from any direction, I walk against it and it's solid. That's what I want. Awesome. So got that going. Now I want, when I press, basically how the mechanic I'm going to make is if I'm walking against it and press the B button, I want something to happen. Because I'm not really using my A or B buttons in this module so far, so I can use my B button to push blocks around. So what I want to do is I want it to be, this is my solid. I'm going to close that so I don't confuse the two. My push block. The other thing I'm going to do is I'm going to manually check the gamepad to see if I'm holding the B button. So I'm going to load gamepad. And usually I put, I have constants. I don't know if I do. If I do, it would be hashtag pad B. But doesn't matter Because what that equals is if I put hashtag %sign 00000010. These are all the buttons on your NES controller. These are your directional buttons, your D-pad. Then this is select and start, and this is B and A. So if you look at your controller, how it's laid out, that's what these all relate to. So what I'm doing is I'm checking to see if 1 is pressed. If it's not equal to 0, that would mean it is pressed. I want to do push block stuff. So I'm going to enter down a couple times and do push block stuff. So if I hit to this point, it means it was not pressed. Not pressed. So I'm going to put jump, skip, push block stuff. And then at the very end of the code, I'm going to skip push block stuff. All right. So what do I want to have happen if I do push block stuff? Well, there is a macro. If I go back to NES Maker and I go to scripts and I go to define scripts, there's a macro called change tile at collision. And this is absolutely going to happen at the point of my collision. However, I cannot get the position of that the way that this currently is because, okay, I'll show you what's actually happening in this. So let's navigate to this. Let's navigate to this macro. And what I could do is I could look at it here. Yeah, sure. We don't have to navigate. I can look at the whole macro here. What we're looking at is argument 0 is the meta tile to change into, and argument 1 is the collision to change into. And before we change tile at collision, temp 1 equaled the offset of the, so this must happen during my collision scripts. Temp 1 gets loaded with, hey, what collision tile are you looking at? And if I'm on an even screen, it does collision table. If I'm on an odd screen, it does collision table too. This is how we're going to fix the statue stuff too when we're on odd screens. But anyway, we'll get to that during cleanup. The important thing to understand is right here, I'm loading Y with whatever's in temp 1. And that's exactly what I want. And we're going to do some math on that to figure out the exact position that we should create our sprite in. The problem is with this is that if you notice, I do a whole lot more at the bottom. And one of the things I do is I load Y with 0. I corrupt Y. Oh no, I corrupt Y. It is no longer what it was at the beginning of this routine, which got me the number of collision offset that I want to work with. So this will work to change the tile, which is the first thing we're going to do. But when we're looking for the position to create a sprite of the block to create this push block to start moving, we are not going to be able to find that position unless we make a slight edit to the change tile at collision macro. So we're going to do that together. First thing I can do is I could just say change tile at collision. And it wants to know, what do I want to change it to? What tile and what collision? And so honestly, I'm going to change it both to 0. Now, if you looked at your game and you looked at your tile set, let's say you wanted to change it to, this tile instead, right? You would have to do the math to figure out what tile that actually is. Right now, we're going to do 0. It's going to change it to ground. But that first value is what tile. And we're changing it to a walkable tile, a no walkable tile. That's tile type number 1. If you wanted to change it to, I don't know why, a hurt tile, you would change it to 0, 1, 2. If you wanted to change it to a warp tile, 0, 1, 2, 3. Get the idea? So now that we've got that, let me save this. And we should notice it's just going to disappear. All it's going to do is disappear right now. So if I walk against it, nothing's going to happen. You can kind of see my buttons pressed right here. Except if I press B, boom, goes away. Kind of cool, and that's a nice way to make destructible terrain. So that might be a base mechanic for a game just by itself. Now what we're going to do is that we're going to turn that into a push block and have it move a little bit. We want it to move basically on the grid. By the time it gets to the next grid position, it's going to turn back into this tile. So what we're going to do is we create this. This is where we're going to have to get into the macro. So to find the macro, what we're going to do is find your folder, your root folder. So this is my root folder, NESmaker 4.5.x. I've got game engine data, routines, base 4.5, System Macros. And right here, I can see I got one called Change Tile at Collision. This is what I was just looking at. Okay, I'll even make this a little bit bigger for you. This is where I loaded Y because temp 1 is holding the offset. And this must just happen in my tile collision scripts. Temp 1 is holding what tile I'm talking about. So what I'm going to do right here, after I loaded Yanni, the Y register, I am going to push it to the stack. So push Y register to the stack. That way, I can do anything I want to it down here. Here's where I'm corrupting it, and I'm increasing it, and whatever. At the very end of this routine, I'm going to pull whatever's on the stack, on the top of the stack, which is right now whatever I put on there, which was Yanni, and I'm going to put it back in, transfer it back in the Yanni. So now, going into this, Y is going to be the same coming out of it as it was going into it. That's all I needed to change. I'm going to hit save. And the reason I'm going to do that is on my push block. I now want to create an object. So I'm going to create an object. And what I need to create an object is an X and a Y, and what object I want to create, and what state that object is in, what action step. But I have a problem because I don't know the X and the Y I want to create it at. But when I did this, I used Y right now because of above macro. Y is my offset. We're almost doing the same thing that we did yesterday with doing the math, where we're going to get the Y value from the top nibble, the top 4 bits of whatever's in Y. And that's going to give me, if I turn on my grid, if I turn on my grid, the top nibble is going to give me what Y value I'm in, 0, 1, 2, 3, all the way down to 0E. And then I'm going to multiply the low nibble, the low 4 bits by 16, moving them over. And that's going to give me, it's either going to be 0 or 16 or 32, et cetera, 48. And so that's going to give me the X value that I want to create it at. So using the same kind of trick that we did yesterday, I'm going to transfer Y into the accumulator. And I'm going to say, and 11110000. This is going to give me my Y. So I'm going to store that into temp A. The Y value I want to create it at. And then I'm going to do the same thing, except I'm not going to and this in. Instead, I'm going to take these values and push them over here. So this masked off the bottom bits. This is now going to take the bottom bits and make them the high bits, this is going to be where my X value is. So I'm normalizing whatever my X value is to 16. So by to multiples of 16. So TYA, ASL, this is how you would multiply by 2, multiply by 4, multiply by 8, multiply by 16. And I'm going to store that in temp B, which is the X value I want to create it at. So now I'm going to create the object at temp B, because I need X first, temp A, Y second, what object I want to create. And if I looked over, what object was I creating? 0, 1, 2, 3, 4, 04, and at action step 0. I'm going to hit save. So now what should happen is this should disappear, and I should see my sprite-based one pop up. Now remember, it's going to be the wrong color. Ready? Right. Oh, and that looked like it created the wrong spot. So what did I do wrong? Let me see. It did create at the wrong spot. So let's go back and figure out what I did wrong with my math here. Temp A. I don't see anything wrong with my math. Unless temp A and temp B gets corrupted and create object, which is possible. So what I'm going to do is I'm going to call this temp Y and temp X. And then I'm going to put temp X. You know what? I'm sorry, these aren't capitalized in this module. And my new one, they are. Let's see if that solves the problem. Nope, it is creating it at the position of my player instead of the tile position. So change tile collision. Did I successfully do this? Oh, you know what? I'm sorry. We have to go back to my change tile collision. I'm loading Y with temp 1. I also need to take Y, TYA, and push it into the register. I wasn't pushing, I was putting whatever was in the accumulator into the register. I need to make sure that I'm pushing Yanni into the accumulator. Sorry. Man. Little stupid mistakes like that. All right. So now, A. One last important thing that we need to do, and we are seeing what happens when you do not back up your registers. What's happening is this actually creates a new object. It corrupts Xavier. And so when we continue on with the routine and it goes to draw things, it puts the wrong object in the wrong position, etc. That's why we did things like this, where we pushed Yanni to the stack and then we restored it at the end. We want to do the same thing right here. Before we create this object, we need to push Xavier to the stack. Then we'll create this new object, make it a little bit easier to see where that's at. And then we will pull what's on the stack off and put it back into Xavier. And that means going into this routine, creating this will not corrupt X and will continue drawing as normal. Sorry, that was just a brain freeze because we're dealing with that exact thing right now using the stack. That's exactly what we had to do with the Y register. So now if we do this, now it creates it at the position. You notice it also creates it 1 pixel too low. And that's because NES sprites skip the very first scan line. They start drawing after the first scan line. So they're always 1 pixel lower. So there's a couple ways to handle that. We could create it 1 pixel higher if we wanted to. And the way we would do that is we could say that the X value is this -1. But I'm not going to do that right now. That would be, that's more than what we want to do with this. So that's step 1 of how we create a push block. Tomorrow, we'll actually make it move based on the direction that I was pushing, and we'll try and get it to situate into a target. And then when it gets to a target, it'll disappear and it'll do something. And we'll figure out like how we can make it do multiple things. All right. So hopefully that was fun. I'm sorry about the little brain freeze. It's funny, again, because that's exactly the lesson that we were learning about backing things up to the stack. And I forgot to back the Xavier up to the stack before I corrupted it with this macro. So hope you guys enjoyed that one. This is I think a lot of people can make use of push block mechanics and come up with all kinds of creative things to do with them. I hope this isn't too bad as far as assembly language. You're starting to get used to some of the syntax. Hope you guys are digging the series. Please share, like, subscribe, all that normal YouTube stuff, and be on the lookout for tomorrow's video.